All right. Yep. So this is for the Team 2 meeting. So, but yeah, pretty much we're gonna be talking about two OP sections and then the par questions. So I know Heather, you said you wanted to discuss the question. Which section was that?
It was for the OP exercises, section 1.6, number 20.
Number 20. Okay.
There, go up a little bit. It's that page right
Oh,
there.
okay. Yep, I got it here. All right. So if you want to go, just discuss what you about it.
So I tried to do this with the idea when with more simpler problems, it's, you just swap y and x and then you solve. And so that's what I tried to do for this one. I may have I think I overcomplicated it. Um, so I don't even know if it's correct or not.
Okay. Yeah, so let's see. This one is in the theory of relativity, the mass of the particle speed is m equals. Okay. Um, so yeah, let me pull this up here. Okay, let me pull up mine. Let's see. Okay, so here's what I did for mine. So, yeah, the theory of relativity is the mass of the particle with speed v is m equals f v equals mo over square root of 1 minus v squared divided by c squared. Where mo is the rest mass of the particle and c is the speed of light in the vacuum. Find the inverse function of f and explain its meaning. So what I did is so here's the original equation right there. And so it wants us to find the inverse. So to find the inverse, I multiplied both sides by the square root of 1 minus v squared divided by c squared over m to get that. And once you do that, you get square root of 1 minus v squared over divided by c squared equals mo over m. And then pretty much you just solve for v from here because you're looking for the velocity or yeah pretty much the velocity, so you reduced it down, and then the final answer I got was v equals v times the square root of 1 minus mo squared over m squared. And let me see here.
Yeah, I got it wrong.
Yeah, so let's see here. So you had that right there. You were on the right track, it looks like. It looks like you just took the equation itself and just multiplied it by square root over 1 minus v squared over c squared over m, rather than doing it to both sides. At least that's how I'm seeing it here.
Okay.
And then you solve from there. Whereas since it's the inverse, because we have both m and the mo, we need to do it to both sides rather than just mo.
Okay.
Um, I don't know. Do Chan or Gabriel, do you have anything to add in on that?
I'm not sure if my result isn't even correct, 'cause
Okay, let me pull up yours here.
that's all the way down. It's like on
Yeah,
page 13 or something.
yeah,
Page 12. 12. Yeah, alright, right at the restart.
yeah. So we start. Okay.
Let me read these.
So
So
I try to write down every single step. So
yeah, yeah. Um, you have a different answer from me as well. Um, because yeah, mine here was c times, and yours was. Um, Yeah, so you were pretty close. It looks like you just kind of had c squared on the inside of the square root. Let's see. Um, get rid of square root, multiply both. Yeah, so it looks like you had the right idea because you multiply both sides by square root of 1 minus b squared over c squared, but you forgot to put that over m as well. So when you multiplied both sides, um, you pretty much made it so it equals mo, but the mo isn't over m, and that's where you ran into your issue because then you subtracted for m squared, whatnot. So this was number 20, right? 20? Yeah, so we can't really check the answer for that. Also, Gabriel, I didn't see your OP questions posted, so I don't know if you want to post those so I can try to access them. Um, but yeah, so we all had different things we did. Let's see. For my self-assessment, um, yeah, inverse functions fairly well. And then for my revised, I kind of just solved for it again just to make sure I did it correctly. Let's see. Yeah. The it keeps like popping up. Here we are. So
Okay, so when you went and you divided by, or you multiplied the square root of 1 minus v squared over c squared by both sides, you end up with the original mass alone on the other side, correct? And then,
no. So when you multiply both sides, so take for example here, if we're taking side m, because m equals the mo over square root of 1 minus v squared over c squared. So when we multiply, so say we're just taking the m side. When we multiply that, you think of it as square root of 1 minus v squared over c squared over m times like m over 1. So the m's cancel each other out, and so that's just going to be square root of 1 minus v squared over c squared. And then if you
oh,
take
so you multiplied it by, okay, I see. You
yeah,
flipped it, and okay.
yeah, the thing you have to keep in mind, as Lisa as I saw it, is MO and M are separate. They're not the same thing because MO is the rest of the mass, and then M is just mass. Um, so that's why when you multiply the MO over square root of 1 minus v squared over c squared by the inverse, then you're left with MO over M. And then from here, that's when you try to solve for V.
Okay. Okay. Yeah. And then squared it.
All right, that's fine, Gabriel. Yeah, if you just want to post at least what you have, and then we can go over those. Um, so any other questions about this one? So question 20 for 1.6. All right. So I think what we have to do is we'll have to stick with 1.4. So let's see here. So we'll go ahead and move on to OP4 1.5, number 5, which is write an equation that defines the exponential function with the base of a is greater than 0. What is the domain of the function? If a does not equal 1 and 1 is the range of the function, sketch the general shape of the graph and the exponential function for each of the following cases. Whoops, I forgot I drew that. A greater than 0, a equals 1, and 0 greater than a greater than 1. Or a 0 less than a less than 1. So let's see here. Yeah, I believe that's it here. And then
It's on page 9.
page 9.
Yep,
Okay,
yep, right there.
yeah, right there. Um, so let's see here. Yeah, so the equation I got was f of x equals a to the x. Looks like you got that as well, Heather. And then
Yeah, I also
yeah,
have that.
okay. And then for domain, negative infinity to infinity, for you, and then Heather, same thing, and all real numbers for me. Yeah. So and then C was the range if a does not equal 1. And then 0 to infinity. So I accidentally closed. Here's here.
Yep.
1 6.
Page 9. Yeah.
Yeah.
Are we supposed to number our pages?
No,
No,
but
no. I think as long as you have the OP and then the number, the section number, and then the number of the problem, you're okay.
so
Uh,
this is the part I'm confused about, so I'm not sure. Yeah, the 5C.
okay.
Uh,
Yeah. So if I see range of the function when a does not equal 1, um, so let's see here. So let's see. When a equals let's see, this is range correct. So I think you kind of got it mixed up with the domain, because as the once you get into like negative exponents, it doesn't work the same way as a normal exponent. Um, so like let's see here. I'm trying to think of how to explain this. Do you want to try to explain C for this one, Heather?
Um, I think that you were on the right track as far as if you're going with a negative exponent, it's more of isn't that like more of a root problem?
Yeah. So what I can
And
probably
so
yeah.
yeah, it behaves differently and therefore you're always going to go from 0 up, whereas with roots, it's not like that, if I remember correctly.
Yeah, so let's see here. So we can kind of do this. So there's equals 1. So as you see, it can't equal 1 because it's just going to be 2. So we ignore that. Even if we go less than and we approach 0, once you get into the negatives, you can see there's a bunch of missing holes in the graph.
oh
Yeah.
yeah. I read this in the book, so oh yeah.
Oh,
I
yeah.
remember. Yeah.
Yeah. And then as you increase, it can approach, it gets to 0, but it can't go past 0. So as you can see, once we increase it here, even even once we get less than 1, it flips the graph, but it still never goes past 0. So
Okay.
yeah, I think you just got it mixed up with the domain instead.
Okay. Okay.
Uh,
Okay. Thank you. Thank you.
yeah,
Yeah, I get it now.
okay. Any other questions about this one? Or actually, we in the general graph shape, I think we all had that there. Let's see. Oops. Yeah, it looks like we all had that general. Yeah. So yeah, and I said I feel like I could explain these a little better, and I went back and did. Um, but any other questions about this question in general? So next one in this would be OP4 1.5 number 6. So how is the number e defined? What is the approximate value for e? And then what is the natural exponential function? Um, so for I think we need multiple people to explain it. So do one of you, Chan or Heather, you want to try to explain this one?
I just put everything that I had found as far as the definition for that. I put a bunch of different things. So that's why in red, because I had originally just put it on there as the natural number. And then I started writing out the stuff before reading the remainder of the question.
Okay.
And that's why the red part is in there. Because it was just, I was adding those as definitions, but they ended up being questions,
Yeah.
answers to the
So
for the question.
I think I have a better answer for this one. So let's go to page 10. So I just like took it directly from the book. The book didn't say these specific words, but I kind of replaced e in kind of the sentence, and yeah, it's just like straight up of the book. So
Yeah, but I think this question was more just kind of stating what you know more than really solving for anything. So it's just kind of understanding what E equals and when it's used. So nothing too fancy with this, and yeah, like I said, it's I think with this, with my notes at least, it was pretty much just noting what it was. Yeah, number E, natural number, Euler's number, approximate value 2.71828, and then Y equals B of X to the X or E of X. I don't know why I wrote B. That should, yeah, is replaced by E, so Y equals E of X. There we are. So yeah, I don't think there was any issues with this. Pretty much just dating it. I know we all kind of did that. But any questions or anything else with this one?
Mm,
Yeah. Um. Oh, okay. I just got notes from Zoom here. Yeah. So let's see. We just did number 20. So then the last one for OP4 was 1.633. So Chen, do you want to explain this one?
is it is it uh is it what problem again?
Number 33 from 1.6. I think believe it was page 14 on yours.
Okay. So yeah, so I don't really know what to explain. So what do you need me to explain?
Mainly just kind of go over the question and just kind of explain why you picked your answer or how you got it.
Okay, let me look at the question real quick.
Yeah, I have it up here if you want me to read it. It's going to be how is the logarithmic function of y equals log ax defined? What is the domain of this function? What is the range of this function? And then sketch the general shape of the graph of the function if y equals log ax if a is greater than 1.
Okay, so log is always the inverse function of so uh yeah, so if we replace y with fx, so yeah, then we kind of have the function that's the log is an inverse of, I think.
Okay.
So
And then how do we know the domain and the range?
yeah, the first thing I know that the log cannot be negative, so yeah, and domain just like anything from 0 to infinity.
Okay. And then we have the graph there. Let's see
Yeah.
here. Do we all have pretty much the same graph? Let's see. Yeah. I think with mine, I just kind of drew the inverse as well. Yeah, so you can see both.
Okay.
But pretty much the same one there. I just kind of wrote out my explanations there. Any issues or any other questions with this one?
Do you mind if I just give me a second so I could read your self-assessment and your revision? Because
Yeah.
I didn't quite know what I should write down on those.
Yeah, so for like the self-assessment and for revision, pretty much for self-assessment, I wrote out pretty much how I felt about the problem originally answering it. And then for revision, you don't always have to just rewrite the problem or resolve it. But for my case, I just kind of added any information that could be helpful. So even though it wasn't mandatory to the question, I just say what something I can look back on if I need help remembering why that is. And then reflection is kind of, similar to self-assessment, but as the problem as a whole after you finish going through everything.
Oh, shoot. All right. Are we moving on to the PAL question?
So not quite yet, because I believe how she wants us done is we have to go through 2 OP sections. Yeah, 2 OP sections and 2 PAR. So first 2 questions. So, is there another specific OP section you guys want to go through? You guys have any questions about some specific ones?
So let's go with OP3 1.2.
E3 1.2. Okay. All right. Yeah. So
Good one.
for this one, I kind of combine the questions, and well, at least for the questions 1 and 2 for 1.2, I just put them on the same page because they're kind of the same problems. Unless I butchered it and looked at the wrong one. Let's see here. Let me scroll to it on your guys's one.
On page 5.
Page 5. All right.
I'm gonna start naming them like or numbering them like you did. That was a good idea.
Oh yeah. So OP3 1.2. So 1.
So I just want to hear what you guys like. What's your thought when you decide to name a function? What's the log function? What's the root function? And
Yeah. So for me personally, yeah, I just kind of made note of it, and then for my revision, I went and expanded on it, where I think you guys kind of did that right off the bat. So as far as logarithmic, for me, it's pretty much anything that really involves log. Um, you can punch them in. Um, if I were to probably add anything else, I might add a graph of each example on how you would know what it is. Let's see here. And root. I said it was root if x is usually the square root of something. So for like example 1b here, it's the 4th root of x, and that's how you know. Rational is pretty much most of how I saw it. If it's like kind of a division question like this, 2x cubed over 1 minus x squared, because x cannot be a certain value where the denominator is 0. So if there's ever a scenario like that, then it has to be rational because there's going to be kind of a gap in your graph somewhere. Polynomials were kind of easy, pretty much just your standard equation. Trigonomic was anything that involved, sine, cosine, tangent, cotangent, all that stuff. And then exponential was anytime like x, p, or anything else was the exponent of something else.
okay.
So, I mean, let me compare them side by side real quick. Because here's mine, and here's algorithmic, root, algebraic. Let's see, C, algebraic.
I got algebraic for C too.
For 1C?
For 2C.
Oh, for 2C, I got 2C. I got polynomial.
Yeah, 2 I got polynomial too, and degree is 5.
Yeah. Let me pull yours up here as well.
Because there's
Okay.
2 R
Yeah,
and
yeah. Well, yeah. So pretty much pretty much how you have to take it is you have to multiply the x squared into this pretty much in this equation, because right now it's FOILed out. So once you multiply it in, then it's 2x squared minus x to the 5th, and then that's a polynomial function with the degree of 5 since x to the 5th is the highest. It's just kind of written backwards. So that's why I got. As far as, let me see. Algebraic function. So an algebraic function is the function which satisfies there is a polynomial in and with integer coefficients. So can only be a finite of elementary operators. Let's see. So, yeah, it can be the root of a polynomial equation. For number 2, we also can't look up the answers here because no even numbers for that. Let's see here. That's where I was kind of confused as well, though. I can see where you got algebraic because algebraic questions kind of are like polynomials.
Mhm.
But
But no, I see how it could be a polynomial too. So
yeah, so that one I see where you got it from. So I'm honestly not quite sure. I took it in as a matter once you multiply it out, then it becomes a polynomial. Um, so let's see here. Does this kind of explain it? Table values, y intercept. No, it doesn't. Yeah, this is kind of vague. So yeah, that'll be something I'll have to go back and check. But I think for pretty much everything else, we kind of got the same stuff here. D-trig, irrational, and F. Or I see for F for number 2, you put algebraic as well. Do you know why you put algebraic for F?
I just that one I think I put it down because that was an example or like very similar to an example in the book that was for an algebraic function.
Let me see here. I'm honestly not sure on that one.
I have to put like either algebraic
Okay.
or root.
Yeah,
I'm not sure either.
Yeah, that one I'm not too sure on. Looked like a root to me since it was the root of x. Yeah, the root of x in the denominator. I'm not quite sure. Let me plug this into Desmos and let me see what it comes out as. Um, so what was the x to the third minus 1 divided by x. So looks like to me this is a root function since it's not going negative. And if we look up what a root function is, it pretty much lines up with the graph here. So this is the equation, and then this is where a root function. Because to me, an algebraic equation would also split off negatively
Okay.
as well. But there can't be a negative y value for this. That's why. Any other questions about this one?
I think I'm good.
Okay. And then the next one for OP3 was 1.3 number 5. So yeah, this was pretty much just transformations of a graph. This is pretty much just understanding the multiplication, division, and plus or minus for a graph. Let me see here.
Yeah, so I try to plot like 4 points down to make it easier. So you can calculate directly from the point there and do the graph later. So it makes it easier. Yeah.
Yeah, that's how I had to do it.
Okay. Yeah, I'm just kind of comparing graphs here. Oops. Oops, I did not mean to do that. There we are. So that's the A. Yeah, it looks like we pretty much all have the same graphs, at least from what I can see. I mean, yeah. They look all the same to me. And yeah, I think this is kind of similar to like that, what is E kind of question. This is kind of just showing what you know, and nothing really to solve for. So it's just moving the graph and understanding it. But any other questions about this one? Okay. So with that, we can kind of start going on to the par questions. So for the par questions, um, so we'll go through all of these, and then at the end we'll go ahead and just create 2 questions, about the par questions that we had. I think some teams already posted theirs, so we can also kind of use theirs as an example. But let's see here. I'm going to close that out. Did you post your par problems, Chen?
Oh, I didn't have chance to do it. I'm gonna sit out of this one.
Okay, so you don't have the problems. Okay, uh, so for looks like it's just me and you for this one, and then Heather. Uh, so yeah, this one is if f and g are both even functions, is f plus g even, and if f and g are both odd functions, is f plus g odd. What if f is even and g is odd? Justify your answers. Um, so let's see here. Pretty much with me, I originally I just kind of stated that what they were. I see here you actually use the equations to show it. So f and g are both even. Um, is that right up here? Okay. I meant to write out even here. Apparently, I just forgot to do that. Yeah, I do not like writing for long periods of time. So yeah, f and g is even. We're both even, then f plus g is even. F and g are both odd, then f plus g is odd, and then f is even, g is odd is neither. And you add the equations. And then for my revision, I went ahead and added those equations in. So for example, like f plus g to the negative x equals f to negative x to g to negative x equals fx plus g of x equals f plus g of x. So therefore it's even. And that's pretty much the inverse for that one, and then neither for the last one, as f plus g of negative x equals f negative x plus g of negative x equals f of x minus g of x cannot equal plus or minus f of g of x, or f plus g of x. So neither. Um, this is kind of just explaining what you know as well. Let me see here. One sec. All right, that's fine. Um, so pretty much this goes into the next one as well with the multiplication. Um, where if f and g are both even, is f times g or even, and if f and g are both odd, is f plus g odd, and then if f is even and g is odd, is what is it? Pretty much. Um, and then let's see here. Let me make sure we have that one. Even, on, even, odd. And this one I went ahead and included it originally with the equations. And zero reflection, you pretty much gave your reason why there's a positive times positive equals positive, negative times negative equals positive, and positive times negative equals negative. And I agree with that too. That's pretty much how I looked at it. Any questions about these two, Heather or Gabriel?
Mm.
Right. Do you have any questions, Shan? I know you said you don't have these, but alright. And then let's see here. Do you want to go ahead and just read off the number 15 or the principles of problem solving one?
That one, I read your thing and that totally went over my head. I just went to the simple.
Yeah, I see what you did with yours, and I did the exact same thing as first, where I just added them together and divided by 2 pretty much to try and get the average. And like I said in my self-assessment, I'm like, I'm pretty sure that it seems way too simple for that to be the correct answer. And I went back and looked into it, and I was correct.
So
So
how did you come to 40?
So yeah, this is kind of the way to change the distance right here with the equation. So distance equals rate times time, rate equals distance divided by time, and time equals distance divided by time. And so 30 you have 30 miles per hour and then 60 miles per hour. And then so that 30 it would be 30 equals distance over time, and 60 equals distance over time. And to make it simple, I made T1 equal D over 30 miles per hour, and then T2 equals D over 60 miles an hour.
I'm sorry, back up. On the very top one, you have the distance, you had the formula. So the distance equals rate times time, rate equals distance over time. The last one, should that be time equals distance over rate? Or is it distance over?
Yes, you're right. I just miswrote it.
Okay,
And that one's on me.
all right. Let's see. Distance over T1. Because I wouldn't have caught that. Okay, distance equals rate times time rate. Okay.
Yeah. So let me know when you're ready, and I'll
Yeah,
change it.
go ahead.
Okay.
I'm
Oh,
sorry.
okay. I just want to make sure you had everything written down you needed. So yeah. So you know your rate, but you don't know your distance and time. So that's where I flip the equation to make it so T1 equals D over 30 minutes and T2 equals D over 60 minutes. So that way we're calculating for the time of the total time that they were traveling. Um, like right here, I said T equals total time, and later I made A equal average speed. Um, so total time is T1 plus T2, and that's what we need. So then I took T equals T1, which is D1 over 30, and then I made plus D2 over 60, and then you pretty much solve for that. So then you multiply this by 2, so you can add them. So 2D over 60 plus D over 60, and then you get T equals 3D over 60, and then you just reduce it. So T equals D over 20. And then you have average speed. So this is where, let's see here. Yeah, this is where R equals D over T. So A equals 2D, because so we know the two distances, so we'll have to multiply them together to get the total distance, multiply them together to get the total distance, divided by D over 20, which is the time here that we got. You solve for that, so multiply both sides by 20 over D. You have 40D over, what is that, over D1 over 1, 40D over D, 40D over D, and then you get solve for that, and you get A equals 40 miles an hour. Um, Okay.
Does Gabriel
So,
have questions that he
uh,
wants to ask?
he said he uploaded his stuff, so I'm gonna pull that up real quick. So do you have any questions about that, Gabriel, for number 15? Also, do you have any questions about it, Heather?
No, it makes sense once I saw it, kind of went through it, I get it.
Mm.
But like I said, I wouldn't have remembered.
Yeah,
all
like I said, I did the exact same thing where I just, added them together, divide by 2 for the average, and I didn't think that was right, so that's why I looked into it a little bit more. What formula did I use for number 15? So the formulas that I used, where is it here? So these are the 3 formulas you can know. So distance equals rate times time, rate equals distance over time, and then time equals distance over rate. That should be an R right there. And then so it gives us 2 of the rates, so which is 30 miles an hour and 60 miles per hour. And so that we pretty much then need to find the average time. So that's where I then work through all this, or average speed. I mean,
average.
any other questions though, Gabriel, or any questions about that, Chan? Or so you use distance, rate, and time to get the right answer. Um, yeah. So, well, how you should look at it is so like the 30 equals distance over T1 here. So time T1 being the time for 30 because they said they spent half going at 30 miles per hour and half going at 60 miles per hour. So 2 different times. We don't know the exact value. You could say it's 1 hour for each of them, but we don't know that. So you do T1 and T2. So this is the R equals D over T right here, this middle one. And then I converted it to help find the time into T1 equals D over R, which is what this one is. Like I said, ignore that second T. I just miswrote it. Um, and then you solve for T here because T is going. You're looking for total time, so total time is just T plus T. So those are the 2 times. And then you just add these 2 equations together to get the total time. Then you want to find the average rate. So that would be R equals D over T again. So, total time, which is 2D for these 2 distances, divided by the time, which we solved for, which is D20. And then you work that out. All right. All right, yep, so that's pretty much it for the par problems. So now we need to come up with a question. And let me go and pull up the rubric for that here. Um, Now, do one of you guys just, because just one of us need to type it, so do one of you guys want to take the responsibility just putting it in there after this meeting's done?
Don't look at me.
Oh,
It's
that's fine. Let's see. Where am I trying to go? Very far. Let's see. all this stuff is a mess trying to figure out where everything needs to. There we are. So yeah, we already have some questions here. So like for team 1 and team 3 here, and, they put the par 1.1 problem 790 related to adding multiplying odd functions, and they use those as illustrations. A more clear ideal example of adding multipliers. How it can be shown mathematically, how it can be shown graphically, and then same for the OP3. Let's see. So we need 2 par related questions. They did an OP question here. So 79 problems FX. So and then yeah, it's number 15. So let's see. Gabriel, do you want to take the responsibility of just posting, typing out these questions and just posting them in this discussion board? Because I'm gonna post the video once we're done, or even Chan if you want to.
Yeah, I can type, but like, what's the question? What's the
So
question we want to come up with?
yeah, so we can come up to 2 questions. So I think one we should at least do is talking about with number 15 because we all pretty much came up with the 45 with the 45 miles per hour. So I think we should do kind of a question like, it states finding the average, and we figured it out that we needed to do the day equals rate time, those equations I had, but we were um, you know pretty much taught that the average is add them all together and multiply by or divide by how many there are. So why is there 2 different ways to get the average? And is there an you know yeah 2 different ways to get an average with 2 different answers? And how do we know which method to use for each? Um, so I think that'd be a good question. Obviously, I'm kind of coming up with that, so there might be a better way if you want to type it out, phrase it, or if any of you guys have a recommendation on how to do that, a better way to phrase that.
Yeah, why is there 2? Which way is more appropriate to solve for the rate or for the average, and why is the one preferred?
Hmm.
And then
Yeah.
I think the 1.6 number 20 problem, the mass particle thingy, should be our second question.
Well, the questions are just for the par problems.
Okay.
Yeah, that's. I think later on we'll start doing questions for the OP problems, but for this week it's just the par problems.
Okay.
So Chan, do you want to write that out real quick, just so when we're done you can post them, or?
Okay, I'll write that.
Okay. Let me know when you're done with that, and we'll move on to the next question.
Thanks, Sharon.
And Gabriel, do you have anything you want to pitch in as far as what to do for a question? Maybe with like 79 and 80 for the par problems.
Okay, so here's the question I wrote. On question 15, there are multiple ways solution to come up with an answer for the problem. And we want to know if one method is more preferred in this particular problem and why is it better than other solutions. Yeah, that sound good?
The only thing I would possibly change is rather just than just saying find multiple ways for finding the problem. Just try to change it to multiple ways of finding an average.
Okay.
That way, it kind of clears it up.
Okay, multiple ways to find the average speed.
Hmm.
Okay.
Yeah. Number 15. Okay. Yeah, we should probably come up with something for 79 and 80. You could possibly make a question relating around is there a variable or something we could add to the problem where it's like f is even and g is odd? So what is f plus g? Is there something where we can, is there a way we can add a variable to that problem to make it either even or odd instead of neither? So that's a question I come up with. I don't know if you guys have another one you guys want to do or what.
Mm-mm.
Okay. So we need to clean that up. Do you want to try to write out the question, Chen, and then we can tweak it from there based on what you wrote?
Okay. So that's problem 79, right?
Yeah, 79.
So can you repeat what you said again?
Yeah. So then, if f is even and g is odd, f plus g is neither. Is there a variable or something we can add to the equation that will make it f plus g either even or odd?
And I don't think I can word. I don't think I can write it down on top of my head. So can you say that again, like slowly? I can write it down. I can trick it from there.
Yeah, so if f is even and g is odd, then
Okay.
f plus g is neither. Is there a variable or something else we could add to this equation that can make um, f plus g even or odd instead of neither?
Okay.
Finish writing that up.
So F is even and G is odd. F plus G would be.
F plus g is neither.
Okay. So is there a way to add a variable?
or anything to the equation to make f plus g even or odd.
Okay, so so what I wrote down is since f is even and g is odd, and f plus g is neither, is there a way to add a variable or something else to the equation for f plus g to be even or odd?
Yeah, that sounds good. Yeah, so those shouldn't work for our 2 questions. So um, whenever you have those typed out, you can just post them into that the question
Okay,
discussion.
I
Um,
just post. I gonna post it in chat first to make sure we're on the same page in the chat.
in that looks good to me.
Okay, I'll post it right now.
So that pretty much should be it then for this meeting. Do you guys have any other questions or concerns before?
I do not. Thanks, guys, for doing all that.
Yeah, no problem. So the next one should be 2 weeks from now is with module 2 and 3 for the OP and PAR problems. So we'll set it up then. We'll probably just stick with this time if it works for everyone. If not, then we can readjust from there.
This works for me.
4 p.m. Good.
Yeah, 4 p.m. Sunday. It's 2 weeks out from now, so we can reschedule from then if we need to.
Okay.
But yeah, if there's nothing else, we'll go and disconnect, and I'll upload this video here in a little.
All right. Thank you guys for coming.
Yeah, no problem. Thank you guys.
Bye.
Bye.